So we are going to start trigonometry today, even though the book doesn't start it until lesson 43. We choose to split it up over 2 lessons. So we are only going to do the part of trig in this course that works if you have a 90-degree triangle, a right triangle. If you have an equilateral triangle, you are not going to know how to do any trig with that this year. Next year you'll move beyond that, but this year it's got to be a right triangle or it doesn't work. We've done enough with right triangles that you know the side across from the right angle is the hypotenuse. And then you've got 2 other angles. Pick one, and then once you've picked it, you can think about the other sides in a certain way. Once you've picked it, you can say, oh, this side is across from or opposite B. This one is right beside B, so it is adjacent to B. However, if I picked the other angle, this side right here is not going to be opposite A. Opposite from A is going to be this side over here, and this side will be the one that is adjacent to A. So we're going to be talking about the acute angles in a right triangle, and we can do trig with those 2 angles, and it's going to matter which one we pick in the triangle, how we have to set the problems up. So I want us to start by thinking about similar triangles. And so here I have 2. I've got the 90-degree angle labeled. I've got the 30-degree angle labeled. And that means these angles up here at the top are both 60. So these triangles are similar. Their angles all match up. We know similar triangles have to have sides that are in proportion. So if I took, for the 30 degrees, if I took the side that was opposite over the hypotenuse, or in this case it's the short leg over the hypotenuse, I would have 2 over 4. And if I did the corresponding sides in the other triangle, or any other 30, 60, 90 triangle, I better still get a half, because that's what it means to be similar triangles. And if I do that over here, if I take the short over the hypotenuse, 60 over 120 is still a half. And for the 30 degrees, that was still the opposite over the hypotenuse. You don't need to copy all of this down because that's what I just said, that we know where the hypotenuse goes. And for any 30, 60, 90 triangle, they have to all be similar. So the short leg over the hypotenuse, or the side across from 30 over the hypotenuse, has to be a half. We call that ratio of the opposite side over the hypotenuse, we call it the sine of the 30 degrees. In fact, we have 3 trig ratios that you're using this year, and you may want to wait a moment to copy this down on your formula page. The next slide is going to repeat this. For the sine, which we will abbreviate SIN, but you never say it's sin, it is always pronounced sine. COSIN is cosine. It is abbreviated COS. It is never to be pronounced cos. And this one is tangent. And we are going to abbreviate that TAN, but pronounce it tangent, not tan. If we pick one of the angles, and I named it theta, just so I could say the sine of this angle, the cosine of that angle. Previous one, I named them A and B. This, I can name them with English letters, I can name them with Greek letters, all kinds of things. So for sine, it is always the side that is opposite over the hypotenuse, but cosine is always the adjacent one over the hypotenuse, and tangent is always the opposite over the adjacent. And we memorize that and remember it by learning this little made-up word, Sohcahtoa. Most of us can manage to remember Sohcahtoa after a few tries. And what that tells us, this one starts with S, that the sine is always the opposite over the hypotenuse. The middle part starts with C, so that helps us remember that the cosine is always the adjacent over the hypotenuse. And the last one starts with a T, so that helps us remember that the tangent is always the opposite over adjacent. And no matter how big or small the similar triangle is, if I've got 30 degrees, the sine will always be a half. If I've got 42 degrees, whatever I get for that ratio, no matter how big or small the 60, 42, 48 triangle might be, I always get the same ratio on that. So let's do get these written down on your formula pages so you can remember them. I'm just drawing the triangle one time and using that picture for all three ratios. You may want to include in there that this one is pronounced sine, this one means cosine, this one means tangent. And be sure that you get in there our little made-up word here that helps us remember which one, sine, cosine, and tangent, is which side over which side. So let's try this out a little bit. So they give us a triangle. Two of the sides are labeled. And I am going to start with, I need to find the sine of theta. And I need to figure out the cosine of theta. First one, I didn't need the E. And I will need to also get the tangent for theta because that's what the directions say I need to find. So they've given me the triangle. It is a right triangle, and they tell me, pick this angle. So now I need to remember Sohcahtoa. So sine is what over what? Out of Sohcahtoa, who can tell me what we need, Melissa?
Opposite over hypotenuse.
So I'm looking for opposite over hypotenuse. I find my theta and my picture. Madeline, what side, what number is opposite the theta? The 5, and what's adjacent, and what's the hypotenuse? So this one, I just write down 513, and then I say, can I simplify it? No, it's reduced. Okay, for cosine, Sohcahtoa. What do I need for the ka syllable? Emma? Over. So I need adjacent over hypotenuse, and I'm in trouble. I've got my hypotenuse, but my adjacent isn't labeled, is it? How do I deal with that right triangle and figure out what that missing side is, Rachel? Exactly. Let's use Pythagorean Theorem, and I'll call it A since it's adjacent, but I could call it anything I want. And I have A squared plus 5 squared is 13 squared. What's 13 squared? 169. Subtract the 25s, and A squared is 144, so what does that mean A is? If I remembered 5, 12, 13 is a triple, I could have just written it down, or I could have done Pythagorean Theorem to get there. So now that I know A is 12, I can say adjacent over hypotenuse is 12 over 13, and I can't reduce that. Austin, Toa, what do I need over what? Can you look at this picture and tell me what number is opposite theta and what number is adjacent to theta? so I need 5 over 12, and I can't reduce that, and that's all that I needed to do to solve that one. Thumbs up, down, in between. Does that example make sense to everybody? Okay, the next type of problem that they will sometimes give us is to say the sine is 8 over 17, and find the cosine of that same angle, and find the tangent of that same angle. When they do that, I'm going to draw myself a right triangle, any right triangle, but it does have to look like it has a 90-degree angle in it. So, let's draw a triangle. And then I need to pick an angle and label it theta, because that's the variable that they happen to use here. It does not matter which one I pick. It does not matter if it ends up being scale or not, because I don't know right now what the scale should be. So I pick either of the acute angles. I can't pick the 90-degree angle, so I'm going to put a theta here. That means for theta, this side is opposite, this is hypotenuse, this is adjacent. I don't really need to write those words in there, but just since it's brand new to us, I'm doing that to help us make sense of this problem. Sine, Caleb, is what over what? Sohcahtoa. What did you write down on your formula page? SOH. So it is, what does O stand for? What does O stand for, people? So we need, so sine has to be opposite over hypotenuse. It does not matter how big or small my triangle is, if it's got an angle that measures whatever theta is, that ratio is going to be the same. So all I have to do, since I need 8 over 17 to be the opposite over hypotenuse ratio, I am going to write the 8 on the opposite side, and I am going to write the 17 on the hypotenuse side, because then when I take opposite over hypotenuse, I get that ratio I'm supposed to have. How do I get the third side? Bryce.
Third side.
If I know the 17 and I know the 8, how do I get the side that I've got at the bottom? I have a right triangle and I know 2 sides. How do I get the other side?
Use the
Pythagorean Theorem. So my adjacent squared plus my 8 squared is 17 squared. Anybody know what 17 times 17 is?
289.
289. And then let's subtract 64 from both sides. And that adjacent side squared has to be 225. So what does A have to be? Now my triangle's labeled Pascal cosine, Sohcahtoa, what over what? So can you look at the triangle, see where we put our theta, and tell me what number is adjacent and what number is on the hypotenuse? Thumbs up, thumbs down. What do others think? Did we get that right? Adjacent over hypotenuse? McKenna, what did we write down for tangent? What over what? Sohcahtoa.
Opposite over adjacent.
And can you look at the triangle and tell me what number is opposite where we put theta and what number is adjacent?
8 is opposite and 15 is adjacent.
Very good. Anybody with questions on that? Okay, let's learn how to enter a little bit of this on our calculators. To do that, you need to be in degree settings. So, anybody not using an inspired? And I'm not, I can go through for the inspires and the 83, 84. Do you know if yours is in degrees? If you can't get it, go borrow one of the inspires to make sure you're in degrees. Anybody else with something? And yours, I can go through the Texas Instruments 83, 84s and the inspires. But the others, if you don't know how to get it in degrees, go grab one of the ones over there. For an inspire, if you have an updated operating system, you can look in the top of your screen right by the battery indicator, and if it says DEGs, it's in degrees. If it says RAD, we need to change it. If it doesn't say it because your operating system has not been updated recently, then we need to make sure that we have it where we need it to be. To do that, we need to be on the home screen, and then we are going to pick settings, which is number 5. And then we are going to pick document settings. And then we go to where it says angle. Mine says degrees. If yours didn't, you do the drop down and pick degrees. And then you go down to the bottom, make it your default. If your operating system still says that, click OK so that you save that. Nobody had an 83, 84, right? So I won't go through that. So everybody good for today anyway? You've got something where you know you're in degrees. Okay, to calculate tangent of 84, you are going to go to the Trig button, which is right beside the 7 and an inspired, and push that. And then you've got all of these choices there, and mine's deciding to be weird. And then you go over and you pick the one that says TAN, not with the -1 underneath it, and click that. And inside the parentheses, you simply type 84, and then you push enter. And it tells us that the tangent, if we round to 3 places, would be about 9.514. Everybody got that with your calculator? Okay, let's do another one. This one means 3 times the cosine of 45.6. Don't push the times. Type it just like that. Type the 3, then trig, but pick CLS. And then in the parentheses, put 45.6 and enter. And raise your hand when you have that. And we'll see if we all come up with the same value. Guess what did you get? Sure about that last one? Everybody get 0.098? Yeah, because we're rounding the 3 places. We're not truncating. We don't just stop. We always round. So 2.099. And one last one, and then we'll do some of the homework together. So type this in. Let's see what you get. Thumbs up, thumbs down. So any questions for that one? Okay, let's try a little bit on our homework then.